Hello guys and gals. Today we are looking at how do we know if a chemical reaction is safe. And one of the ways that we can do that is by predicting what the products of a chemical reaction are going to be far before we ever walk into the lab. Now there are several reasons why that would be a useful thing for us, but it's something I would like to talk to you about in person. So for today we're going to talk about just how to predict the products of a reaction. Or if we needed to do it backwards, these steps would also work for how we could predict the reactants of a reaction. Okay, so I have a 5-step method that's going to help us predict products. Step number 1 is to determine the type, okay, of the reaction occurring. Now this is probably the most important step because we have no idea what the products are going to be without the type of the reaction. That's going to determine everything that we do next. Step 2, we're going to determine the charges of every element involved because we're going to need those for later. Now, this has a couple of exceptions. We don't need to do this with combustion, okay? Do not need to do this with combustion, and we also do not need to do this with decomposition. Now, it's not going to hurt you if you do it in either of those situations. It's just not going to be necessary for us to have the charges of those in these situations. Now, in every other type, we are going to have the charges of the elements. So in step 2, we'll determine the charges, and we're going to set those aside and save those for later, okay? Now, in step 3, we're going to follow the definition of the reaction type. So, for example, if you've discovered that something is a synthesis reaction, well, the definition of synthesis is that those two elements come together to form one product. So you would take the two elements that you saw in your reactants and you would squish them together to make them one product. If the reaction type that you identified was single displacement, then the definition of single displacement is for the singular element to replace someone in there. And of course, it replaces the element that is the same charge as it. And so you would set it up to do that. Okay? So step 3 is to follow the definition of the type of reaction that's occurring. Step 4 is to crisscross or, well, it really should be and or, determine if you have diatomics, okay? Because if you have any element alone, like you would in a single displacement reaction, you need to crisscross your compound, but for any diatomic element, you need to make sure that you have written it correctly. And remember, that's anything in Brinkelhoff. Okay? And step 5 is the step that we're not going to get to today, but it is going to be balancing the reaction, and that's something that we'll talk about later. Okay? So let's just do a couple examples together where we are predicting the products of a reaction, okay? And we'll follow these 5 steps. So I'll do it right here at the bottom of this so that we can see the 5 steps and we can keep up with everything. So let's say that we have the reactants Na plus Cl2, and we want to know what the products are. Well, step 1 says to determine the type. Since I only have 2 elements reacting, the type must be synthesis, because everything else that I have involves compounds being my reactants. So since these are only 2 elements, it has to be a synthesis reaction. Step 2, determine the charges, and we're going to save those for later. Well, sodium has a charge of +1, and chlorine has a charge of -1. Step 3, follow the definition of the type. Since synthesis says that these two are going to come together to form one compound, I am going to just put them next to each other to show that they have bonded. And step 4, follow crisscross rule. Well, lucky for us, this is a 1-to-1 reaction, so we have followed the crisscross rule. So, the product of a reaction between sodium and chlorine is sodium chloride. Now that one was pretty simple. Let's do another one where it gets a little more difficult. Let's say that we have lithium reacting with silver 2 chloride. And we want to know what the products of this reaction would be. Well, step 1 says to determine the type. So I see a single element and it's reacting with a compound. Well, the only type that has an element reacting with a compound, other than combustion, but none of the things in here are hydrocarbons or oxygen. So that's going to give me a really big hint that this is going to be single displacement. Okay, so there's step 1. Step 2 is to determine the charges. Well, I know that lithium has a charge of +1, and I know that chlorine has a charge of -1. But here's the problem. Silver is a transition metal. So, what is the charge of silver? Well, I can use reverse crisscross rule to help me out with that. There's a secret invisible 1 right here next to silver, right? And we already know that that 1 came from chlorine's charge. So this 2 here next to chlorine must have come from silver's charge. Step 3, follow the definition of the type. Single displacement says that this element is going to replace one of those elements in the compound. Now, since lithium and silver are both cations, then lithium is going to replace silver, and we will have lithium chloride, and silver will be left alone. Now, finally, we need to crisscross and or check for diatomics. Luckily for us, lithium and chlorine both have a -1 charge, so our crisscross is done, and silver is not a diatomic element, so we are finished. So we just predicted, before we ever stepped into the lab, that if lithium reacted with silver 2 chloride, we would get lithium chloride and silver. Now, there's one more example I want to do with you because it does not follow any of these rules, and that is combustion. Okay? In a combustion reaction, we're going to have something like this. A hydrocarbon reacting with oxygen. And as soon as you determine the type of this reaction, you're done. Because when you identify this as a combustion reaction will always produce carbon dioxide and water. And that is it. You don't have to guess. You don't have to crisscross. You don't have to do anything other than follow the definition. And the definition of combustion says you will always produce carbon dioxide and water. If you were wondering why we don't need to determine the charges of elements for a decomposition reaction, that is because most of the time in this class, a decomposition reaction is just going to give us our original elements back. So in a decomposition reaction, you will only need to check for diatomics, and you don't need the charges to know if an element is diatomic or not, okay? So I hope that this was helpful. If it's not, go check out your daily notes, and there are more videos there on how to predict products. And as always, you can email me or you can send me a reminder.